So I thought of doing this experiment in Blender versus AI, since we see that AI is taking over most of the jobs today. The experiment is simple: how to make a cube fragmented into multiple small pieces that slowly fall under gravity. There will be two parts in this tutorial. First, we'll see how to do this in Blender, and then we'll see what AI can do or who wins this battle. So let's start with this default cube in Blender. But instead of dividing this cube into multiple small pieces, we'll use array modifiers to line up many such small pieces together. There will be 10 such cubes in each line, so collectively we'll have a total of 1,000 small cubes. Now for this cube, we have to change the scale factors to 0.1, which is 1 divided by 10, and we need to also apply these scale factors. Then let's go to the Modifiers tab and add a modifier called Array Modifier. The instance count should be 10 for each row, and here we can control the distance between these instances. Let's keep it as 1 for a compact design and apply this modifier. Then we'll add the same modifier once again for the Y dimension with the same count of 10, but this time instead of X, we'll create the array along the Y-axis and similarly apply this modifier as well. It may look like a simple solid rectangle, but if we turn on the wireframe view, we can see the small cubes. The object is composed of hundreds such cubes so far. And we need to also extend it in the Z dimension, so let's add another modifier in the same way. The count can be 10, or you can change these values if you want a different number of pieces, but we're using 10 on all sides, so we have got 1,000 small cubes. And it's a single object, so we can set its origin to the center of its geometry. Now let's remove its location offsets to place it right at the world origin. And at this stage, you can rotate the cube as you wish. Later we'll see that this part was almost ignored by the AI models. They failed to rotate the cube even after very specific prompts. Let's now go to the edit mode, since we want to create individual cubes from each of these parts. So go to the Mesh menu, and under Separate, click on Separate by Loose Parts. We can see that all these cubes are created from the original cube, and we can go back to the Object mode. With all the cubes now selected together, we'll set their origin to the geometry, which will set the origin for all individual cubes to their own center points, which is an important step. Now select any one cube from the heap and go to the Physics tab. We'll enable Rigid Body Physics, and it should be an active rigid body. We can change the mass to say 0.1, and for a simplified rigid body collision, we can change this shape to box. Then we can customize the other things for more accurate physics behavior, like we can change these values for friction and bounciness. You probably already know about them. So we have an active selection here. Let's select all the other cubes using a box select, but please ensure that no other objects are accidentally selected other than the cubes. Then go to the Object menu, and under Rigid Body, select Copy from Active. It will set up the rigid body physics for all the cubes alike. And remember that you can always select them together like this, and you can still rotate them or move them together at frame number 1. So we have switched over to the camera view mode, and we have added a floor object for collisions, which should also have the rigid body physics enabled in the Physics tab, and remember that it should be a passive type object. You can then customize the other settings as you wish. We'll simply go with the same values for friction and bounciness that we have used for the cube objects earlier. Now if we run this, the cubes will fall on the floor, but it will look very fast when we render the output. So if we want to play it in a slow motion for visual pleasure, we have to go to this Scene tab. Then under the section called Rigid Body World, we can change the speed factor here. Let's make it 0.5 for 50% speed, and we have to then bake the physics from here. Once the baking is done, we can play it, and we'll see how beautifully the animation runs. Everything is perfect here. The physics is accurate. We can place the cubes in any particular style, no issues at all. The camera angle is correct. The lighting is just as desired. We can use any specific material, so overall we can create whatever we wish. Now let's switch over to the AI tools. We first tried this in Sora, and the output was not really good. The physics is anyway not perfect, and it looks like an explosion despite a very clear prompt. So we cannot give it anything more than 4 out of 10. Now in Runway ML, the output is even worse. We supplied a reference image for the first frame and the last frame, taken from Blender, but still it can hardly get a score of 3 in our opinion. Our next bet is Kling, and the physics is good. We supplied a reference image in this case as well, but it did not maintain the number of cubes we wanted, so overall we can give it 7. Let's also try in VO2, which is from Google. The first trial did not go very well, but in the second trial we got a decent output, however still not good enough, so we give it only 6 out of 10. Finally, with VO3, we got the best output, so we'll give it a score of 8. But the lack of our control on the output and the lack of accuracy in these AI tools make them inferior to what we can achieve with Blender. So without any doubt, Blender stands out as the clear winner. You just can't replace it. However, generative AI has its own application as well. It can be used in other type of creative arts. We have published some interesting videos like this on our second channel, and the link is given below. You may want to watch them at your leisure. So I hope you like this quick comparison. Thanks for watching, and don't forget to subscribe to this channel.